and to increase productivity at the same time. So, to talk about leveraging technology, especially AI, photomicrography, and blockchain to transform the gemstone assessment industry, I'd like to invite on stage Mr. Vincent Wong, the CEO of GIC and Porolis Technologies Private Limited, Singapore. Over to you now, Mr. Vincent.
Hello, hello. Can you hear me? Okay. Very good afternoon to all of you. I'm quite privileged to be given the chance here to speak to you. It is something very different. I know we have a lot of jewel and gemstone traders out here, but what I'm going to try to share with you is a project that we have been undertaking in the context of Sri Lanka. I think every day we know about AI, right? AI is used in medical, in mining, and a lot of other places. But I think this is probably one of the very, very few projects in the world where we apply AI and technology and blockchain to try to transform the industry. So bear with me, about 30 minutes or so. And if you have any other questions, we're actually in booth number 1, just at the main entrance, please. All right. Okay. Ancient craft, modern challenges. I think we would agree that this is a 1,000 years kind of industry. But what is and has allowed us to modernize the trade is AI. AI, and of course, I'll introduce a bit about blockchain as well. So we call it GemTech 3.0, but the underlying technologies that we are referring to is AI. Photomicrography, we have actually invented a machine that you can go to our booth and do and try it out. And of course, blockchain as well. So just to give you about a bit of a background on the company, we belong to the BPD Silver Group. It's a Sri Lankan-based group, 150-year-old family business, headquartered in Singapore, about 300 employees, and we have other businesses like in tea and jewelry as well. So as I say, we formed Porolis as a startup about 3 years ago. And by the way, the P is actually the BP. P is Porolis, so we use that name to call that company, AI and photomicrography. Let me elaborate a bit more. This is where we started our project. I think you know AI is everything about data, data, data. So GIC is already a 20-year-old company in Sri Lanka. We have a lot of data. So about 2 years ago, we were wondering what can we do with this data to improve productivity, maybe, for sure. But at the back of our head, we always thought maybe we can make it into a product and offer it to the industry as well. So we got a lot of data, mostly images, and of course the parameters of this data as well. So our solution today, we have launched it early this year. We call it the GemLux system. We have an equipment called the Chroma. It is essentially a scanner to take the image and the video of the gemstone. Now, what is important and has allowed us to actually leverage on the AI is on this side of the picture. This is where the AI has been trained to make certain inferences. The most important example, for example, is color, right? Color is a big problem in the industry. There's a lot of confusion. So I'll give you some examples afterwards how we use AI to tell the color to help the gemnologists to be consistent. Now, we don't stop there. We actually deliver the overall solution as a cloud-based system. So you can actually join as a member. Okay? Please come and join as well, where you can have a user ID password for gemstones that you scan is on the cloud, and you can access it anytime you like. Now, this is our ambition. Hopefully, 1 year from now, maybe sooner, we will issue a AI-driven gem report. Okay, so that is the ambition, but bear with me. Let's go on with this. This is just a specification of the Chroma, but essentially it is a camera, microscope, colorimeter, and a computer, and is of course AI powered, as I say, in the cloud. Now the images here don't turn out too well, but we actually take 2 important images, 2 important videos. One is a color faithful. We need to take a digital representation to be as close as possible to the physical stone. That's very important. Second thing is we put the stone in the immersion liquid and we are able to capture the video of the inclusions inside the stone. All right. So on these two bases, then we send it to the AI for training. I will just skip through this development product roadmap. We have a long way to go. We are making another machine here as well. I will skip that as well. So this is a typical example. Oh, it's not turning. Okay, sorry. Oh, I can't go back. Sorry, we transferred it from the thumb drive to the computer there. I've lost control of it now. It is supposed to be the video anyway of the 4 very color faithful stones. Okay. One slide back, please. Can I have one slide back, please? So maybe the video is very big in the file size, so somehow it crashed. But as I said just now, we take 2 main images. One is the appearance, so the color is very important for us to preserve. There you go. Okay. It was a big challenge for us because light-colored stones and dark-colored stones require different kind of illumination. So we had to run a lot of experiments to ensure the color faithfulness of the gemstone. Right. The 4 should turn at the same time, but nevertheless, maybe he's trying to do it one after another. Oops. One slide before, please. Thank you. Okay, it might not turn, but actually you can appreciate that it's a video that you see with the inclusion highly visible. This is very, very useful because I think there's a huge risk to buy rough. So if there's a way to visualize it as you see right now, I think your quality and decision making in assessing the gemstone will be more invaluable. Okay, so again, 2 photos, right, of the same thing. This is the cut stone of sapphire, color faithful, and the inclusion map. Color faithful and inclusion map. So keeping this in mind, this is now the AI side. Okay. So first application in AI, all right, is color classification. Okay, sorry, it's not turning, but nevertheless, we have 60 over 1,000 stones, 60 over 1,000 stones represented in the LAB space. I won't elaborate too much why we use LAB color space. I think it's something that is useful for you to read up separately. But what we are trying to do then is, out of these 60,000 stones, there are about 30 classes of colors that we are talking about here. All right? So 60,000, maybe 5,000 is green, 3,000 is yellow, 10,000 is paparaja pink orange, and royal blue, and so on and so forth. So now what then we use AI is to represent the centroid, the middle of royal blue, for example. We put it in this. So these little dots, each of the dot represent a specific color. Okay, paparaja pink, orange, yellow, and so on and so forth. So it is important to understand this because this is precisely what AI is trying to do, right? AI learn how you behave, how you judge things, and then now we statistically, mathematically represent it as a 1 point for that color and so on and so forth. But this representation, remember, is as good as our gemnologist saying that it is this color. But anyway, AI is supposed to learn that. Now, I mentioned just now about LAB color. Please study about it because LAB is a very interesting concept. We are very familiar with HSV, hue, saturation, value, to represent a color, right? We are very, very familiar with representing physical space as X, Y, Z, right? So in school, we learned that. And we can also appreciate the color distance if we also correlate it with physical distance. me and this place, okay, we do x square, y square, z square. I'm 2 meters from this place. Me and that gentleman, I'm x square, y square, z square. I'm 5 meters from him. So I'm closer to this guy, okay? Now color gives you the same thing. So if you represent your color in LAB space, you can actually calculate color distance. So just imagine if we already have a standard, say royal blue is here, just now in that graph, then you bring in a sample, and I can measure this, and if I'm closer to royal blue, I'm royal blue. I'm further away from that blue, or whatever it is. So conceptually, it is something very, very interesting, because LAB space, I won't talk too much because it's a very big subject, is perceptually uniform. It is a standard that matches how human beings see colors, okay? So that is like the concept of our color classification. Some results. Okay, some results from our AI. We have trained our AI model. We let it go for testing. This is the correct answer. Correct for blue class, BL class. The top 2 rows are wrong answers. Any AI system, anyway, whether to test COVID or whatever it is, you sometimes have wrong answer. But the key thing is the accuracy is quite high. All right. And then this is Paparaja. We tested it, and then our AI model predicted it, and most of them are correct. So we are already achieving accuracy as high as 90%. Of course, the more samples, the better. So we are working with hopefully other gem labs as possible, and then put it into the 60,000 just now, and try to make the thing statistically more robust. Okay. So that is color classification. So I hope you can kind of appreciate the concept. The other AI application that we have is to use the inclusion pattern to detect treatment. So that is precisely what our gemologists do in GIC. They're actually putting the stone under the microscope, study it, and if they see certain inclusion, they will say that, yeah, it's treated or not treated, right? So this is what we are doing. So if you are familiar with this kind of inclusions, there are different types. If our gemnologists see these red color ones, generally they will say this is a telltale sign that the stone is treated. Okay? Now this is then what we do. We have images like this. Our gemnologists will put a boundary box, just like Facebook put on your face. After he do it 3 times, 4 times, 5 times, he know exactly how my face look like. In future, a new photo come in, he knows Vincent Wong is this fella and he's a friend of that fella. So same thing here. So you can see we are teaching. We are teaching the AI satin, silk, and so on and so forth. So with that, in future, when we put a stone, a sample stone in there, it is able to say it's a satin. Because it's a satin, it's a treated stone. Okay, so conceptually, it's something quite straightforward as well. Okay, now one final application in AI. We are trying to tag. Today, one of the biggest challenge in trying to uniquely tag digitally a gemstone is because you cannot. I know in diamond they do laser inscription, but I don't think they do it so often in sapphire. But nevertheless, we use a natural way to try to tag it using AI again. This is the experiments, for example, that we are doing. Row number 1 is 1 stone. Row number 2 is a 2nd stone. Row number 3 is a 3rd stone, and so on and so forth. The purple color one is what the AI is seeing. Okay, we apply algorithm, so it's remembering that thing. And then we put this into the database. Database. And we run experiments to do a matching exercise. So is this the same as this? Yes. Is this the same as that? No. No. Yes, no. So it's a matching exercise. No different than when you go through airport, right? When you do a fingerprinting, I come from Singapore, so yesterday I was in Changi Airport, this morning I was in BIA Airport, and so on and so forth. So that is exactly what we're doing. You want to cut down false positive as far as possible. False positive means I'm carrying that gentleman's passport. I go past the passport, and he says, yes, positive. but it's a false positive. So you want to cut down on that. We call false positive something called precision zero. So in AI, then we fine-tune. We fine-tune the threshold, we fine-tune this and that to make sure the false positive is zero. So we have improved the model, false positive, to become zero. So there are, if you are into the subject of AI, you do a lot of experimentation, threshold, and to improve the performance. So this is the experiments that we run through. So I just want to share with you how behind the scene, this is the third application that we use it. But the use case is very compelling. Now, if we are able to represent the gemstone, okay, with a digital certificate, undeniably, it's is tamper-proof and everything else, then we have this concept called the unique gemstone identification number. So it has a passport number, okay? We can translate it into an NFT. So some of you may be in the space of blockchain, okay? Crypto world and so on and so forth. So that is very useful because in future, we don't actually have to have the stone to trade. We actually have the stone in the bank. We have a digital representation, but you trust that this certificate is representing that physical stone, and you are just buying and selling based on that certificate. People are already doing it. When you draw a nice piece of art, people are already doing it in websites like OpenSea and so on and so forth. So this is what they call NFT, non-fungible tokens. So if you are able to do that, then you can have an online marketplace that is blockchain driven. You know what is the wonderful part about this? If you are able to do that, you can build what they call smart contracts. Smart contracts are automatic computer programs. So you have a NFT, your gems is here, okay? When A sell to B, B sell to C, you can build smart contracts that has a program that says 0.0001% of that transaction price, give the money to the miner. B sell to C, automatic, automatic. B sell to C, 0.001% of B sell to C, miner. Or could be the cutter as well. So you can see now, the miner and the cutter is benefiting throughout the life cycle of the asset. So it's not just, well, I'm desperate for money, I want to sell it tomorrow or next week, So this is very, very, I think, compelling for producing countries like Sri Lanka or Myanmar or whatever it is. And of course, the brands in Europe and US likes it as well. So I think this is a very, very important use case. I don't know how many of you are from the government. It's even better for the government as well, because if the miners today put it in the blockchain, right, it's very transparent. So the government likes transparency, right? So the government can collect more tax revenue, all right, and of course use it for development of the country. So I think it's a very powerful win-win situation where the miners benefit throughout the life cycle, and then the government as well can use and recycle the tax revenue for more beneficial economic use. Okay. How do we offer this service? This is my last slide. Of course, we sell the chroma machine. It's not that cheap, but nevertheless, today we already opened up 3 centers. We call it the GemLux experience. We have it in Barrovella, Rathnapura in Gem Tower, and of course in Colombo in our GIC lab as well. So you can come in with your stone, okay, and then do the scanning. You have it on the internet, and then you can access it, download the video anytime you like. The certificate, as I say, later on we will launch it as well for that gemstone. We are running a promotion now. It's free of charge. We want to also attract users to come in for the next 2 months. All right. So, okay, this is our outlets over in Sri Lanka, the 3 that I mentioned. Okay. So finally, please visit us at booth number 1. Actually, it's FA001 now. It's right at as you enter the main entrance, it's on the left-hand side, okay? We have 2 chroma machines there. please come and scan. It's really free of charge, and then seeing is believing. But I hope you can appreciate the AI application in how it can benefit use cases. I mean, ultimately, AI is only the technology behind it. Market adoption, industry acceptance is quite crucial. But understanding the benefits are most important. Okay, thank you very much for your time. Thank you.
Thank you very much, Mr. Vincent Wong, CEO, Pearlis Technologies Private Limited, Singapore, and of GIC. The stall is there, as Mr. Wong mentioned. Do visit the stall and get to know more details as well. Thank you so much for your attention, and do explore the exhibition.